Hi, I'm Cheryl Leach. In this problem, we're going to be looking at a list of characteristics of a function and seeing if we can figure out what the graph of that function looks like. Now, the thing that's kind of interesting about this problem is that there's not a unique answer. There are going to be several different functions that fit all of these criteria. So I'm going to show you a couple of them and see if you can find some other ones on your own. So let's get started. Let's take a look at that first criteria. F of 0 and f of 2 are exactly the same thing, and they equal 0. Well, what this tells me is that my graph has x-intercepts at the point x equals 0 and x equals 2. So we have x-intercepts at x equals 0 and x equals 2. The second criteria tells me that the derivative is greater than 0, as long as x is less than 1. Well, we know that derivatives are greater than 0 when the graph is increasing. So my function is increasing, but it's increasing only when x is less than 1. So it's increasing on the interval from -infinity to 1. My third criteria tells me that the derivative at 1 is equal to 0. That means we have a horizontal tangent line. But that could mean that we have a relative minimum or a relative maximum. I'm not sure which yet. So let's hold on to that for a minute. We either have a relative minimum or a relative maximum. We'll come back and figure that one out in a minute. So let's go ahead and look at the fourth criteria. My first derivative is less than 0. When my first derivative is less than 0, my graph is decreasing. So my graph is decreasing, but it's only happening when x is greater than 1. So that happens on the interval from 1 to infinity. Well, now I can go back to this unknown piece, because if my graph starts out increasing and then changes to decreasing, it was a relative maximum. So I was able to fill in that detail. Last piece of the puzzle. The last piece tells me that the second derivative is less than 0. Well, second derivatives tell me about concavity. And when the second derivative is negative, that means it's concave down. So I've got a concave down graph. And notice that there were no stipulations written about x. So that means it's concave down everywhere. So from -infinity to +infinity. So now let's see if we can come up with a graph that fits all of these criteria. So let's start out with x-intercepts at 0 and 2. So I'll put my x-intercepts at those two locations. The next thing I'm going to work on is that relative maximum that happens when x equals 1. I wasn't told what the relative maximum was, so I can put it anywhere I like, as long as the x-coordinate is 1. So let's start out by putting it right here at 2. I know that before I hit x equals 1, my graph is increasing. So I know that my graph has an increasing behavior. And then at that maximum point, it'll have a nice smooth turn. And after it, it begins to decrease. I also know that I must be going concave down. So my graph is going to look roughly like that. Now that's not the only option. Again, let's put our x-intercepts at 0 and at 2. This time, instead of having a maximum at 2, let's put it at something much lower, like 1/2. Again, I want to be increasing until I hit that maximum and then decreasing. And I want the whole thing to be concave down. So let's see what happens. I can draw it something like that. So those are just two examples. See if you can come up with another way of drawing a graph that fits all of the criteria. I hope this helps. Thanks.